Hello, welcome to our presentation titled, ResNet or DenseNet? Introducing dense shortcuts to ResNet. ResNet or DenseNet? Nowadays, most deep learning-based approaches are implemented with seminal backbone networks. Among them the two arguably most famous ones are ResNet and DenseNet. Despite their competitive performance and overwhelming popularity, inherent drawbacks exist for both of them. For ResNet, the identity shortcut that stabilizes training might limit its representation capacity, and DenseNet mitigates it with multi-layer feature concatenation. However, the dense concatenation causes a new problem of requiring high GPU memory and more training time. Partially due to this, it is not a trivial choice between ResNet and DenseNet. Our work revisits the relationship between ResNet and DenseNet, resulting in a unified perspective of dense summation to link and compare them. Inspired by this unified perspective, we propose dense normalization shortcuts to mitigate the dilemma between ResNet and DenseNet. Adopting these dense shortcuts, our proposed backbone architecture is termed DSNet. Before we go to the details, let's have a preview of the results on ImageNet. Our proposed DSNet 50 or DS2Net 50 outperforms much deeper ResNet 152 and achieves comparable performance as DenseNet 264. Note that our DSNet requires much less GPU resources in terms of GPU memory and computation time. Starting from basic convolution, H represents the convolution weight and F indicates the feature, we can derive the mathematical equivalence inside ResNet and DenseNet. For more details, please check our paper. ResNet and DenseNet are found to have dense connection, specifically dense summation, which reveals the core difference is that ResNet adopts the same convolution weight H, while DenseNet uses different H. Different H is more flexible but less efficient. That's why compared with ResNet, DenseNet can achieve higher performance, but requires more GPU resources. To increase flexibility while using the same convolution weight H, we introduce dense shortcuts, which are nothing more than weighted normalization. We can plug dense shortcut or DS into the ResNet backbone. The proposed naive version of dense shortcut is shown in Figure 2a. Here, we believe that aggregation feature YI has more information than individual feature XI, so we replace XI with YI, resulting in our proposed DSNet as shown in Figure 2b. We further insert one additional weighted shortcut inside the convolutional block, which is called DS2Net. The proposed dense shortcut has two components, normalization and weight. We find both of them are crucial for the performance. Specifically, we find that group normalization plus channel-wise weight is the best design choice. DSNet and DS2Net both outperform ResNet by a significant margin on CIFAR 10 and CIFAR 100. For a wide range of width and depth, DSNet and DS2Net outperform ResNet by a large margin. The same phenomenon is also observed on the well-optimized structure ResNext. DS2Next of half network width with only 25% parameters, can even outperform the corresponding ResNext with a margin of 0.66% points. Compared with the seminal backbone structures, our proposed DSNet and DS2Net show superior performance, suggesting that dense weight normalized shortcuts constitute a competitive dense connection technique. On the large-scale ImageNet dataset, DS2Net 50 achieves significantly better performance than the original ResNet 50, and even outperforms much deeper ResNet 152. DS2Net 50 also outperform its counterpart with SE or CBAM attention by a relatively large margin. On COCO detection dataset, DSNet 50 and DS2Net 50 also outperform its counterpart ResNet 50. The GradCam results show at which part of the image the network focuses on for classification. The results show that DSNet attends more on the objects and has a sharper focus than ResNet 50, which partially explains why DSNet and DS2Net outperform their counterpart ResNet. In a nutshell, we provided a unified perspective of dense summation to facilitate the understanding of the core difference between ResNet and DenseNet. Moreover, we introduced the dense shortcut as an alternative dense connection approach, and the proposed DSNet and DS2Net outperform ResNet by a large margin on a wide range of datasets. If you are interested in this work, please also check our related work presented at BMVC 2019. Thanks for your attention.